Welcome to the lesson on recruiting a team. Upon completion of this lesson, learners will be able to identify the challenges in deploying a team for robot integration and manufacturing, describe how to build a case for integrating robots, and identify and address the concerns of recruiting a team. Learners will also be able to describe key stakeholder concerns when developing a robotic deployment proposal. As industries increasingly embrace automation and robotics, there is often confusion about the true impact of these technologies on the workforce. Convincing companies to recognize the value of integrating collaborative robots, also known as cobots, with humans remains a challenge in today's industrial landscape. Some of the common misconceptions include the belief that robots will eliminate jobs and replace human workers, that automation inevitably leads to widespread unemployment, and that human labor will become obsolete in an automated workplace. These concerns often arise from a misunderstanding of how automation technology integrates with and enhances human capabilities rather than replacing them entirely. Robots are designed to eliminate repetitive and monotonous tasks, enabling humans to focus on more complex problem-solving activities, creative tasks, and strategic thinking. This integration creates new job opportunities and roles while increasing overall productivity. Some specialized roles may include robot programmers, maintenance technicians, and automation specialists. The key is understanding that technology serves to complement human capabilities rather than replace them, enabling workers to develop new skills in managing automated systems. Through optimized human-robot collaboration, companies achieve better production output and return on investment, while creating a more innovative workplace environment where employees can maximize their cognitive and creative potential. The image illustrates the three key areas of expertise required for successful robotic cell deployment: robotic skills, project management skills, and manufacturing process skills. The Venn diagram shows how these competencies intersect, with the arrow pointing to successful robotic cell deployment emerging from where all three domains overlap. The implementation process follows a structured approach. First, a case must be built and presented to management, demonstrating the value proposition of robotic integration. Once approved, the project is announced with careful attention to addressing stakeholder concerns. Finally, the team leads and executes the deployment phase. This approach combines technical robotics knowledge, understanding of manufacturing processes, and project management capabilities to ensure successful automation implementation. Let's talk about building a case for robotic automation in manufacturing. When presenting to management, there are four main areas to emphasize: confirming job security, reducing workplace injuries, enabling better job placement, and achieving higher production numbers. Job security can be reinforced by showing how automation creates new skilled positions rather than eliminating roles. Workplace injury reduction is achieved by having robots handle hazardous and physically demanding tasks. Better job placement means employees can be moved to more engaging roles that utilize their cognitive skills and creativity. Higher production numbers are attained through the consistent output and 24/7 operational capability of robotic systems. Now let's talk about addressing concerns. Whenever creating the collaborative robot deployment process, a written document with your team needs to be created to include the following points: reason or business justification, scope, schedule, and roles. These are important steps in the development of the robotic cell. Recruiting a skilled team for collaborative robot integration in EV manufacturing involves assembling a diverse set of professionals with expertise in robotics, automation, and specific knowledge relevant to EV production. The first concern is why. The why should present solid reasons why a collaborative robot is currently a good idea. So, with this comes increased productivity or increased efficiency. If the why cannot be answered, then it might not be a good place to add a robot. The second concern is scope. The scope should clarify which manual operation your team is looking at automating in your plan. This should define the process duration and identify where the collaborative robot will be best suited. The third concern to address is schedule. A time frame needs to be set for the project completion, not only to ensure that the time frame is realistic, but also to give you a little flexibility. A time frame is important because not only do you need to know when things are supposed to be completed, but it also informs you whenever you're running behind. The fourth concern is roles. Discuss and clarify all roles and responsibilities of the project team members. This is important to ensure that every task is covered and that no tasks slip under the cracks and get left behind. Here is a sample project proposal for implementing robotic automation in an EV manufacturing facility's battery installation process. The Y focuses on market dynamics and operational efficiency. The EV market demand has risen 40% annually, yet manual battery installation takes 45 minutes per vehicle, while competitors using automation achieve 30% faster rates. Collaborative robot systems show over 95% accuracy in similar applications, making the timing critical. Any delay risks losing market share to automated competitors. The scope focuses on automating the battery module installation in the Model X assembly line. This involves implementing robotic systems for lifting and precise placement of the 1,000-pound battery packs, currently handled by 3 workers per shift. The implementation is structured as a 12-week program to ensure smooth transition. The implementation schedule is divided into 4 phases. The first 2 weeks cover site preparation and safety protocols, followed by robot installation and basic programming in weeks 3 to 4. Weeks 5 to 8 are dedicated to testing and optimization, with the final month focused on staff training and gradual production integration. The workforce transition plan emphasizes skill development and new role creation. Current operators will be upskilled to robot programmers or supervisors, while the maintenance team will receive specialized cobot certification. Quality control teams will oversee automated process validation, and production leads will manage human-robot collaboration workflows. In summary, a successful collaborative robot deployment team must have the right people with robotic skills, project management skills, and knowledge of the manufacturing process. The benefits of deploying cobots are reassuring the operators about their job security, fewer injuries in the manufacturing plants, better job placement for employees, and higher production numbers. To address concerns about recruiting a team and robotic implementation, provide clear documentation that includes the business justification, project scope, schedule, and team roles and responsibilities. Thank you.